Welcome back, everybody, to the Additive Snack podcast. I'm your host, Fabian Alefeld, and today we have a really interesting episode and guest for you. Today we're talking to Jake Jones. Jake is a project manager for tooling and additive manufacturing at Penn United. Penn United is, I would say, making quiet waves in the additive manufacturing space. They're not super buzzy about what they do, but what they do is really, really interesting, and I think is a very good blueprint and lesson for other organizations that are trying to figure out how to enter additive manufacturing. They're not a pure additive manufacturing house. They have various different additive or manufacturing technologies, but they've integrated additive wisely. They've grown organically and have done a really good job managing their additive portfolio all the way now into production applications. So we'll talk about what the journey looked like. We'll talk about Jake's role in that, and also we'll talk about, of course, the challenges, but also some of the unique insights that they've gained from that journey. So without any further ado, Jake, welcome to Additive Snack.
Thanks, Fabian, for having me. I appreciate it. I look forward to the conversation, and I'm a big fan of the podcast, so this should be fun.
Cool. Well, I'm a big fan of Penn United, so that's mutually. Let's start with Penn United, though. I think it's worth mentioning the history of that company, and how additive kind of came into the mix.
Yeah, I'll go way back, starting from the very beginning. So Penn United was founded in 1971, actually on my grandfather's farm. He was one of the three founders of the company, where they were really specializing in tool and die manufacturing, small components, tooling, stamping tooling. 3 years into the company, they decided to turn it over to the employees. So Penn United is actually an ESOP, or an employee-owned stock plan company. So everybody has a little bit of stake in the business, and that was turned over to the employees about 3 years into the business. Shortly after that, we started our stamping production work, which we were actually running production of stamped components, and that's kind of where our bread and butter is for production level components, precision stamped parts. Starting in the early 2000s, the business really started to grow through a few acquisitions, a carbide material manufacturing business, dealing with tungsten and silicon carbides. We purchased a machine OEM, a grinding OEM business named Parker Majestic. They still go by that name. We purchased a powdered metal compaction tooling company up in St. Mary's, Pennsylvania, not too long ago. And then our most recent acquisition was a plastic injection molding production house out in Warminster, Pennsylvania, above Philadelphia. So we've grown quite a bit since the turn of the century through these acquisitions. But I contrast that a little bit to the organic growth of the additive group inside Penn United, where that has been slowly growing over the last 6 years. Okay. We're now 700 employees strong total. Probably one of the largest contract manufacturers out there, dealing with precision metal components, that has ventured into the plastics world as well. So yeah, interesting. That's a brief history.
Yeah, well diversified, and it's still on your previous grandpa's property. Is that the same location still?
No, we're still in Cabot, Pennsylvania, which is where the farm was. But no, okay. The location moved as we started to grow. There's still an old building there. What used to be building number 1 is still on the farm. Yeah.
Gotcha. Not started in a garage, but started on a farm. It's very similar to EOS, by the way, which was started in a barn. So,
oh yeah,
Americans or Silicon Valley, I guess, startups are typically come from garages. Germans come from barns, and you guys came from a farm. So
yeah,
Western mixing those two together.
And a corn farm. Yeah,
exactly. Super interesting. And then, so 6 years ago, you guys started to get into additive. So that's what, 2018 then?
Yes, correct.
How did that start? What influenced that decision to get into additive and build that? Well, back then, especially, still somewhat new manufacturing technology.
Yeah, I would say it goes back years researching the technology. The leadership at Penn United saw the potential there. Specifically, our vice president Charlie Phillips was pushing the technology quite a bit internally. So what gave us that final push in 2018 was a customer approaching us and wanting us to operate a machine for them. So our first machine installation was actually an EOS M290 on site here at Penn United, and that final push has given us that, it gave us that extra confidence in seeing the need for our current customer base since we had a pretty good relationship with them.
Interesting. I mean, it's a perfect scenario. You already have a customer in place that funds and de-risks that investment. But you guys have grown by quite a bit since then, right? How did that
Yes.
growth journey look like from 1 to 90 to where are you today?
So we are operating 3 M290s. Those run pretty much any of our materials. We're running probably 15 different alloys at this point.
Wow.
We have one EOS M400 that was purchased for a production opportunity that we saw in the energy sector. That is the 4-laser M400. So that's been a production workhouse machine on one material so far, but we're looking at qualifying a few more materials on that machine as well. And
Cool.
I see us growing very quickly into some larger format machines, hopefully in the near future.
Interesting. And you have some, I think some binder jetting as well as any other technologies, or mainly powder bed and binder jet?
Binder jet is kind of a side project still. It's not something we're really specialized in yet. We're just kind of exploring the possibilities that technology, the sinter-based technologies bring to different materials. We really want to try to offer as many materials as we can to our customer base. And that's kind of a gateway into those harder materials like ceramics and carbides and materials like that.
Okay, cool. Let's talk a little bit about the integration of your conventional business that has now grown into various sectors and additive. How is that a leverage you guys pull? Are they somewhat separated within your organization? How does that look like?
It's very well integrated. So additive manufacturing sits inside of our tooling group. Our tooling group is dealing with the small precision type components where we see a need for maybe some more complex geometries. So we never approach a new project as, hey, this has to be additive. When a customer comes to us with a part or a problem or a project, additive is simply just one tool in our toolbox.
Okay, so it makes sense. Nobody does additive just to do additive. You do additive if there's a certain, and I'm guessing you also leverage the whole post-processing capabilities that you guys have from other sectors than for your additive components.
Yes, we've done very well at marrying the knowledge of our precision traditional subtractive manufacturing with the additive side. Yeah.
Okay, cool. Which industries are you guys in? Maybe it's even talk about the conventional business as well as additive, and do they align, or is additive in a completely different sector?
We have some specialty markets in the additive area, but as a whole, Penn United is in dozens of markets probably. The main ones land in DoD, a little bit of aerospace, medical devices, connectivity, automotive. Big one on the carbide side is oil and gas and fluid handling in general. So Penn United is one of those businesses that really touch everyone's everyday life and they don't really notice it. Beverage cans, for example, a lot of tooling for beverage cans comes out of Penn United.
Okay. That's interesting. So those beer coolers full of cans have touched a Penn United tool. It's good.
Yeah.
Okay,
Yeah.
and then
Yeah,
additive,
right.
which are the main sectors for additive?
For additive, we got started in the energy sector, a little bit of nuclear. That's been a big one, really. Defense, through some projects with America Makes we've been involved in. A lot of work has been done on the defense side. They've been focusing a lot on reducing lead times for components or replacing cast parts with additive components for better lead times, or replacing obsolete parts, right? Things that nobody's manufacturing anymore. Nuclear's done a good job at creating their own specifications and accepting the technology. They're definitely not stuck in the past. They're trying to move things forward with new technologies like additive.
Mm-hmm.
We see a pretty big potential in oil and gas. AWS specifications, APS specifications, those specs are out there that kind of enable those engineers to approach additive. And okay, there's now a clear route on how we can qualify a component through this manufacturing process.
Okay, interesting. And do you guys also then consult potential or existing customers on the value of additive, or how do you engage with your clients, and how do you bring them into that additive journey? Because that's, typically, depending on who you're talking to, sometimes a challenge. If the knowledge and experience level of additive is still quite low, how do you prove the viability of the technology?
Yeah, proving viability just goes, it's kind of a history thing, showing that you're getting the better properties out of the material, most of the time better than castings, right? So that just the history of having those tensile properties on hand, being able to show them, hey, this is a part that is meeting your strength requirements. You can use this in your application. A big one is just having them on site, having customers come visit Penn United to see the technology in person. When you see that laser running over that powder, you might be thinking, most people haven't seen that before. It's brand new to them. But then you hand them a part and say, this is what that machine is making right now. You're not going to be able to bend that part. It's just as strong as that part you were getting before.
It still gets me every time, I'm 15 feet away from machines, and every time I walk past them, I'm still amazed by
exactly
the sheer potential of the technology. What I think is always interesting is how companies manage to build teams for additive. I think it's quite well known that is challenging to just hire for experienced talent in additive. And I'm kind of curious to understand, you guys grew somewhat organically from one system to two to now, a really good fleet of additive equipment that comes typically also with the challenge of building talent, retaining talent. I mean, we even had to move this call for an hour because you guys were interviewing somebody. So how have you guys managed to build talent, experience, and knowledge within the organization for additive?
It's a very good question. It's something we deal with quite a bit. So Penn United we do have our own training facility for subtractive manufacturing. And in a way, we've kind of gone back to that old internal training where we're bringing employees in from other areas of the business. So that could be, we could be pulling somebody from the wire cut department or from our tool room, guys that are running those 3-axis, 5-axis machining centers that we got here, and training them up on additive machines. They are, in general, cross-trained, to simply put it, to run both additive machines and subtractive machines. And they have a pretty deep knowledge of the entire process from start to finish. A lot of it's been trial and error at the start, right? As you get into, how do you clean out a machine? Okay, we're going to need a work instruction for that. How do you level the build plate? Make a training regimen that keeps people informed and keeps the best practices in the forefront of their mind while they're training on this technology.
Cool. So you guys typically then pull people from the inside and do a cross train versus hiring somebody completely from external. Is that a good
Yeah,
assumption?
on the operational side of it. So our technicians and operators, yes.
Okay.
What we don't have a whole lot of is maybe materials knowledge. So for engineers, we do look to the outside. We need those people that do have some additive experience or maybe a higher level education to help us provide that expertise to our customers in explaining and providing a good material to them. Because that's what you're doing. You're making the material in the machine. And a lot of customers need that extra feedback from us. So we need those engineering resources to kind of explain how this material is, hey, this is just as good as what you're getting somewhere else through a forging or casting process. But we're out in the middle of nowhere, Western PA. So finding engineering resources can be a little difficult sometimes, just like everybody else is seeing in the industry.
Yeah, for sure. For sure. Let's stay with the operation for a second because it's so key to, especially to a production environment, which you guys are in. What's been your experience? Do you typically look for somebody that has more of a machining background? You touched on it a little bit where you have hired previously, but have you seen some like trends where if we hire somebody from that department, the transition is the easiest, or is that hard to say?
I wouldn't say we don't see a difference really from interdepartments. The culture here is precision and setting up these machines, especially laser powder bed machines, require a little bit of precision, right? Your build plate needs to be flat. That recoater blade needs to be sharp and flat and parallel. We emphasize that everywhere in our business because that's all we do is precision metal components on the tooling side. So moving somebody into this technology, they typically have the right mindset going into it.
Okay. Makes sense. You hire from mindset. I think that's a really good analogy. Yeah. You look for folks that have a precision manufacturing mindset. Interesting.
Exactly.
Let's talk about your production environment as well. So you've got multiple systems. You're running applications in a serial production environment. How do you manage shifts? How do you manage planned downtime? How do you manage just pure continuous manufacturing on a laser powder bed fusion technology?
Yeah, so a little bit of serial production here for sure. We need to keep machines running. That's how you make money in this business, right? Is taking advantage of that machine time and keeping that uptime high. So we do time out our builds. If there are multiple components on a production level build, we try to time it out so that it is ending on a working shift so that that build has time to cool down, that operator has time to vacuum that material, pull that build, get a fresh build plate in there and keep running. We've had projects that are running or taking advantage of the machine nearly 23 hours a day. It's either being set up or heating up or cooling down or actually building parts. That's where you really need to focus your build times and maybe even tweaks to the parameters or layer pauses and trying to keep that machine running with the quality of the part in mind.
Okay. Yeah, it's a good point that I think a lot of people underestimate in their early parts of the additive journey is we've even seen people take parts out of a build in order to hit those 23 hours build time just to ensure more uptime of the system. It's almost counterintuitive because you want to maximize the build envelope, but maximizing the uptime and therefore overall equipment efficiency is I think a higher priority in that case.
It is. And when machines sit, which does happen sometimes, those machines are losing us money basically sitting right there. So that we have the same issues as a lot of the other service providers in the industry right now, where machines sitting will cause some hurt and you need to make up for that somewhere. And that's part of why we cross train employees as well. So we don't have employees sitting around not doing anything. They can be out in the shop working if we are a little slow in the additive department.
Oh, interesting. Okay. So they all have a dual job description in a way.
Right.
Interesting. Okay. One of the key capabilities of Penn United in the additive space, I think, is also your deep process understanding. Can you take us a bit through how you guys approach process parameter development? How do you see that as a competitive advantage as well for you and the organization?
Yeah, we put a lot of work into how fast we can develop new materials. The first step is do your research, right? Make sure that's a material that in theory should be weldable. It should be something that can be laser welded in this type of process. And then we go into a development cycle, which typically can be as little as 3 builds, to where we are getting a material that is dense enough to meet specifications and meet all the minimum strength requirements that may be. So a build typically includes a very wide range of parameters. Like one build will test dozens of parameters. We will pull miniature tensile bars that we developed in-house to test the theoretical strength, that we relate that back to like an ASTM standard E8 tensile bar, right? But at the same time, in parallel, we're working on contour, surface finish passes, upskin and downskin, and density blocks, so we can be looking at porosity and microstructure all in parallel. We basically end up with this matrix of parameters, which I know is not the only ones to do this, but that matrix is now pointing you in the right direction toward an optimal parameter set. And a lot of times we can get there in 3 builds.
Wow, super interesting. Any materials you can publicly talk about? Maybe if you can give us a hint on how the demand came about.
We've been asked for materials. Every customer, we're in so many markets, right? That there's so many materials out there that people come to us asking for. And most of the time they can't switch that up. So where the benefit comes from to our customers is we are willing to do that development. We might need some NRE up front, right? But if that component is qualified to that material, they might spend more money requalifying to a different material in their application than what it takes for us to develop printing that material they're already using.
Okay, very cool. And then from a complexity perspective, I always think it's very interesting to see folks that first get into additive to overestimate sometimes even the complexity. It can be very daunting to get into additive, but then once you kind of have it dialed down, it's pretty straightforward. Whereas machining a certain application, can actually be more complex than an additive application. Yeah. What's your right. point of view? You've seen all sides of the manufacturing space, or many sides of that space. How do you view the complexity of an additive operation versus some of the other operations you guys run?
It's definitely different in just the fact that you're adding material instead of subtracting it, right? Where we see the most benefit is geometries that can't be made traditionally. So implementing filters or high surface area to low volume ratio, heat exchanger type parts, and that they still go hand in hand. To make a part functional, you're gonna probably have to machine it at some point, right? But the complexity is they contrast, but they're also very similar in the same way that a customer just needs a part that's going to meet the drawing. And that's what we're pretty good at, developing those complex features in parallel with maybe something else we're working on that build or on that part. So we will tweak parameters to get to a complex channel, a small, horizontally built channels, or maybe really, really thin walls. While we're developing the part, making prototypes, we'll also be working on customized parameters that are specialized to that geometry, all in parallel at the same time.
Is that almost every project by now? Like, do you get a standard part that you built with standard parameters, or are you guys at a point where you're so specialized and you run a lot of complex geometries where a custom parameter is almost the new standard?
In a way, we never get the easy stuff, it seems, right? So yes, a lot of times we are customizing parameters just to one geometry. But luckily enough, we've seen enough of them at this point, probably have something to refer back to and apply to a new part.
Yeah. And I think, honestly, I think that is one of the key benefits of especially laser powder bed fusion, is that ability to customize process parameters and adjust them for certain criteria, whether if it's part performance or buildability or true cost, right? If you're getting a casting replacement application, you could probably speed up the process a bit, justify a tad of lower density but increase speed, versus a heat exchanger with thin walls. You're gonna adjust for the thin walls and airtightness, right?
Exactly right. And something we also see a lot of is people, if people aren't sure of a part building on a first off prototype, they'll just use a soft recoater, go in there with a silicone blade or whatever. We might do that for first offs, but the goal ultimately is to get to a parameter set that you can use a hard recoater to make sure you are getting that consistent layer thickness and you're not seeing any kind of wear on a recoater blade that might cause a variation in your layer thickness, which in turn affects your density.
Okay. What does serial production mean for you guys? Is it 5 parts, 10, 100? When do you speak of true serial production at the Penn United Additive?
Yeah, shipments of production parts are in the hundreds.
Okay.
Parts typically weigh, mass wise, we're talking about 2 kilograms. So not a whole lot of very, very large parts, and we're not doing hundreds of thousands of small parts either. It's that middle ground that, it's not like our stamping department where we are pumping out millions of tiny precision components. These are highly specialized, typically parts that are benefiting from combination of assemblies in that 3 to 10 inch range that you can fit on an M290 most of the time. But we have shipped thousands of serial production parts.
Okay, very interesting. Where do you see the most growth in additive for Penn United? Is your established industries like nuclear and DoD, oil and gas? Where do you see the biggest potential and growth right now?
It's probably the specialized components that really benefit from additive, in the sense that, like those heat exchangers that can use gyroid structures or very, very fine lattice structures. I think I've maybe shown you the super fine lattice part that we made a little heat exchanger, miniature compact heat exchanger. The struts of that lattice structure were only 0.005 of an inch in diameter. It's those small specialized things that I think we're going to find those applications and benefits to our larger current customer base. I definitely see us being able to specialize in that a little bit. I do want to see the medical field start taking advantage of this as well. Stainless steel parts, aluminum parts. Obviously, we've been using additive in implants, titanium implants, and things like that for a long time. But I do believe the medical device industry can start specializing a lot with hard to reach areas and very specialized treatment.
Okay. So you see more applications where additive provides let's call it a performance enhancement or a innovation character. I guess except for the DoD that you mentioned, that is more of a supply chain case, or what are the key drivers for your customers today? Is it an innovation and performance part, or is it that supply chain aspect of availability and fast lead times?
You're right. The DoD work is definitely invested in just better supply chain resources and faster lead times. But the rest of the industries we focus on are looking at performance increases.
Okay.
Yeah.
Interesting. Very cool. I am always curious, we see a lot of contract manufacturers today that are pure additive contract manufacturers, and you guys are one of the few that have additive as one of their pillars in manufacturing. How do you also manage to create awareness across teams and across departments within Penn United to ensure that folks that get a request for one of their manufacturing technology, like it's stamping or injection molding, which might be challenging, to get that light bulb come on and say, hey, this might be an additive part, and or to use additive also to optimize certain internal operations within the organization. How do you guys approach that?
On the training side of that, or awareness side, I would say it's something we need to work on. We need to do a little bit better.
Okay.
Across all of our 4 business units, I would say there's not too many people that have seen our additive department in depth, people that are doing quotes for regular components, and they might see something random. A lot of times I do just, somebody will shoot me a part and say, hey, can this be printed? Well, yeah, it can be printed, but should it be? And is the customer willing to work with us on making a printable part?
Mm-hmm.
That's the first steps. So I'd say we still need to work on that a little bit, educating everybody on the internal side. As for external work, I think here.
Yeah, I mean, it's not easy to raise that awareness for internal folks, especially because everybody is in their little experience bubble. So I guess, what I think is really interesting, and I've actually been to your training center, it's quite large, that you offer very comprehensive training programs. Do you offer those to customers as well, or are those mainly internal trainings that you?
Yeah, we offer a training to customers on our die side. So design for manufacturing is what we call it. Obviously in the additive side is DFAM, design for additive manufacturing.
Yeah.
We do educate customers on how to make their components manufacturable in a stamping sense, which obviously adds a ton of value in making the actual components less expensive on a mass produced scale. We probably will start offering design for additive training at some point as well. Right now, that tends to be a service that we can just simply offer to customers at the moment, helping them design their parts.
Mm-hmm. Cool. Well, let me know if you need help. We can also do something together. All right. I'm very curious what every expert in additive on how they got into it, because it's typically not a straight journey. A minority of people, went into additive already in school, and then had additive as their career choice from the beginning. So, how did your journey into additive happen?
In college, I would always the engineers would be showing off their little 3D printers or plastic printers in the dorm room, and I would always just get a chuckle out of that because I didn't understand where that would ever come into play in my career, and I never saw it being useful to me. I was proven wrong very quickly out of college. I started Penn United as a tooling project coordinator on our progressive dies. When we got that first machine in 2018, I was kind of just pulled into the room and said, hey, you're going to start working with the customer on these projects, keeping parts moving along. As we grew and we purchased, 4 more machines, that need for somebody to fill that full-time position came about pretty quick. So I've been full-time with the additive group here for probably at least 3 years now.
Okay. Cool. Yeah. See, it always happens somewhat organically and unplanned. Same for me.
Right.
But those are the good career choices then. All right. one more question for you. What are you most excited about when it comes to additive, to Penn United? Looking forward, where do you see the future of additive go?
A couple of things, yeah. There's definitely a lot I look forward to. Educating people on the technology is probably number one. I love talking about it. I love getting the ideas flowing, and those brainstorming sessions where you can think of what's possible to build. I also do look forward to helping build a solid solutions provider inside of Penn United. As we're growing, it's exciting how fast we're growing. It's really good to see, or at least be a part of this beneficial new group inside of the company as big as this one. I also really just enjoy the additive community. There's so many people out there, these conferences like AMUG, and everyone was just in LA a little bit ago for Rapid. Everybody's so collaborative. It's just a really good community to be a part of, and something I look forward to being a part of for a long time.
Yeah, it is true. Being an additive typically allows you to be somewhat entrepreneurial, I would say. It always allows for different ideas. It allows for typically building teams, departments, just growing a business, because for most organizations it is still new, and they're still in their infancy when it comes to implementing it. So it always has that entrepreneurial character, and I agree the community is pretty awesome. I mean, I've never met a mean person in additive that I didn't like to hang out. It's very unique.
Yeah, exactly. And the technology is just advancing so fast that I look forward to just seeing the new machines that are coming out there, the new technologies like EOS's Enlight collaboration, these new technologies that are printing faster, more precise, and making parts cheaper at the same time.
Yeah, 100%. And it's very refreshing to see companies like Penn United to embrace additive, because I think it's important to see that the true implementation of additive manufacturing is one of the tools in the tool belts of manufacturers, where it's not just an island, but it's truly a piece of the puzzle. And it's also, I think, awesome to see how really smart people like yourself are embracing the technology, are diving super deep into it, and try to understand the processes in depth in order to then adjust process parameters, adjust build times for overall equipment efficiencies, and so on and so forth. So thank you for sharing your insights with us, Jake. It was awesome to have you on the show. And I hope I'll see you very soon at one of those conferences.
Absolutely. Thank you. Hopefully I provided some kind of unique input from a service provider that is, doing a lot of things in the precision world.
100%. And I think that's one of the key messages we'll take with us. Hire people with a precision mindset. I think that is really, really good advice. Thank you also to our listeners, to you out there for tuning into the Additive Snack podcast. It's awesome to have you with us. If you did like this episode, please give us a rating on your favorite podcast app, or if you're new to, click the like button, or even leave a comment if you have any questions for Jake or myself. We'll be back with another episode next week, and this was the Additive Snack podcast. Thanks for tuning in, and I'll see you then.